Immutability describes the state of something that cannot be changed. If an object is immutable in programming, then that means you can't or you shouldn't change the properties of that object after it has been created. JavaScript gives us a very handy way of guaranteeing immutability for any instance of an object, and that is through this method, Object.freeze. It works like this. If you create an object in JavaScript and give it some properties, then anywhere in your code that can access this object and change the values of those properties. So you can do it immediately after creating it, or you can pass the object into a function and change it inside there. This object is mutable, and these operations are called mutations. You execute some code that changes or mutates the internal state of this object. Now, if you don't want this sort of thing to happen, then you can use this method here called Object.freeze. After this has been called, any subsequent mutations or changes to this object's properties will be prevented. You also can't add new properties or remove properties. So a delete method like this would do nothing after calling Object.freeze. If you were to invoke JavaScript in strict mode, and there's a link in the video description below if you don't know what strict mode is, but if you were to invoke it in strict mode by adding use strict to the top of your function, well, in strict mode, JavaScript will actually generate errors if you try to mutate an object of properties of a frozen object. So let's get some JavaScript running and I'll show you this in action. I've got Visual Studio Code here with the Code Runner extension, and I'll add use strict to the top of my page. Now we're going to create an object called myObject, and we'll give that a couple of properties. So let's give it a name property, and we'll just give it a value of a random number. There you go, 1. Now if we do Object.freeze on this myObject, and then underneath here, if we attempted to mutate this object, so let's say we're going to do myObject and I'm going to do value plus plus. So that's going to attempt to increment this number value from 1 to 2. Now if we run this, I'm using the Code Runner extension in VS Code. If we run this, you can see cannot assign to read-only property value of object. So this line here, number 10, this is the one that's failed. If we didn't have this Object.freeze here, then this would run perfectly fine. Like that, executed with code 0. So Object.freeze is preventing us from changing this value property on our object. We can do this with a number of other things as well. We could do this with an array. So let's just say instead of my object, this is actually now going to be my array. And we'll make that 1, 2, 3, 4, 5. And again, we'll freeze the array with Object.freeze my array. And then attempt to call myArray.push. And we should see the same thing happening with this. We should see that it says, cannot add property 5, object is not extensible. Extensible means it can be extended. And so that's what we're trying to do here. We're trying to extend the array. The other thing we can check is that if we go back to creating an object again, we can check that we aren't able to delete this value. So without Object.freeze, we should be able to run delete on myObject.value. And what that will do is it will remove the value property off of the object. So I'll do a console.log and show you what my object is after this. And we should see an object with name but without value. Here we go. Yeah, so we've taken the value off because of this delete. But again, if we were to put this Object.freeze back in, then we can see that we'll get an error saying cannot delete property value of the object because the object is immutable. Now it's important to point out that Object.freeze only does what's called a shallow freeze. So it'll only prevent you from changing the immediate properties of this object here. If you have properties that are themselves objects, then Object.freeze will not prevent changes to them. So in this example here, we have two objects, A and B. A is being passed into a child property of object B. If we call Object.freeze on B, then we won't be able to reassign this child property, but we will be able to change the properties on object A. So object A is still mutable, even though object B is immutable. This also applies to arrays as well, because arrays are still objects. So if you have an object with an array property and you freeze that, well then you can't assign to this new array, but you can push items into the array. I find it useful to think of this as the number of dots in the expression. So Object.freeze will stop you changing the value after the first dot, but it won't stop you changing things after the second dot and onwards. You could of course call Object.freeze on this property as well, but that's a separate operation that you need to remember to do. Right, I promised in the title of this video that I'd show you a practical example of this, and here we go. This is in TypeScript, but it doesn't make a huge difference. We just don't need to put use strict at the top of this because TypeScript is always strict, and that's the way we like it. So what we've got here is a function that loads some settings from, let's say, local storage. Let's say you've got some user preferences and they're saved in the local storage of the browser. And one of the issues with loading settings like that is that when you pass this settings object around the application, you might find that people want to change the settings and you might forget to save those settings back into local storage. So what we want to do is, after we've loaded these settings, we want to force people to use this change setting function, which saves them back in the local storage. So if somebody wants to update these settings, like these preferences, somewhere in the application, they have to go through change settings here so that we get a chance to save them in storage. If they didn't do that, then it would only change them locally in memory and it wouldn't actually save them to disk, and that could cause bugs. The issue is though, there's nothing to stop us changing this settings object. So if you go down here where I'm executing the code, I am loading up the settings and then I'm just changing it, settings.language, to a new value. And we're not actually calling anything. So we can do this, settings.language, and it hasn't saved it back in local storage. So what we want to do really is, after we've loaded this settings object, we want to freeze it. So the only way you can update the settings is by calling our change settings method down here. So we want to make it so this line here fails and we're forced to do this instead, called change setting with the setting that you want to change. So the way we can do that is, as we know, once we've loaded the settings object, we can call Object.freeze on the settings object. Once we've done that, that's basically all we need to do at this point. This line here will now fail. So we can test this in the debugger, but we should see settings.language failing because we've frozen our settings object. So we're just going to run this and we'll say settings.language, and that has failed. Cannot assign to read-only property language. So this line here has failed and the execution won't continue. So that's good, we don't want that. We want to call this change settings method. Now this change settings method is taking in settings and it's setting the key that you specified to value. Now again, we won't be able to do this line either because we've frozen settings. So what we would need to do here, and this is a common pattern in immutability and immutable software design, is we'll actually create a new version of the settings object, new settings, and we'll use the spread operator to copy all the existing settings from the thing you passed in, but with the new key value set to the new value like this. So we haven't actually mutated the settings object here, we've just created a new version of it that's got all of the same properties but with this new value set. Then we can save that new value, that new settings object in storage, and we can return it. And we've created an immutable version of the save settings function, which we can call down here. So this should now work, if I typed it correctly. So you can see now we can step in, we can load our settings object. I'll just hover over that to show you what's in it. It's got a display name and a language. And then we can call change settings and say we want to change this language and we want to change it to French. So we clone that object, which is a new settings object, but now with French in the language, save that in storage and return the new version. So what we've done by doing this is we've mutated the settings object by cloning it, creating a new version with that property set, saving it in storage, and then continuing on with our new version of this settings object. You'll notice I've had to use let here because obviously we need to be able to reassign the variable as opposed to mutating the variable itself, which is a much cleaner pattern anyway. So yeah, just to summarise, by using Object.freeze on our settings object, we've made sure that nowhere in the code can change the settings without calling this proper change setting method. What we've done is we've guarded against a potential bug where the setting was changed in memory but not saved to the user's local storage or to their cookies. So our code is a lot more robust as a result of doing this, and it's less likely to have unpredictable things happen thanks to us forcing this immutability with Object.freeze, which we've got at the top here. Anyway, I hope you find uses for this in your own code. If you have any questions about this, then pop them in the comments section below. I'll put a link to the source code for this settings example in the video description, so if you want to play around with that, then go ahead. Don't forget to subscribe to this channel, I'd really appreciate it, and I'll see you in the next video.